Thank you very much. Yes, I did my PhD at the University of Edinburgh. I haven't been back into this building for many years, but I finished my PhD in 1985. So it's 40 years since I last talked in here. And I must admit, I've got a bit of an imposter syndrome because I'm a Northern Irishman, now based in the south of England, but talking to Scottish people about the Hawick Group rocks, Southern Uplands, and extending into Northern Ireland. Sorry. No problem. Okay, good to go. Okay, so a bit of a long title. I've color-coded it to split it into two parts. But basically, I'm going to tell you about an exposure of rock which hadn't previously been known, which I had the privilege to find, located on the edge of the Mourne Mountains. And it tells us quite a lot about what was happening during the closure of the Iapetus Ocean. And I have lots of people to thank, which the next slide will show, but it's not moving on. Technical problems. There we go. It should work. No? Yeah, okay. Okay, so Steve is here tonight, and he's helped with this project, as have Mark Cooper from the Geological Survey of Northern Ireland, Brian McConnell from the Geological Survey of Ireland, Mike Sims of the Ulster Museum, and Richard Warner, who's a retired archaeologist previously based at the Ulster Museum, and my students, and you'll see some photographs of some of my students who've helped over the years. One thing which, if you publish a scientific journal article, you don't really get to explain is the sort of personal background and the discovery of a feature. So I really wanted to put that into my talk. So the first several slides is about the chronology of how I came across this rock exposure of gritstone conglomerate in the Mourne Mountains, and then going through from that, progressing from that into mapping it, showing you photographs of the features, talking then about the petrology and geochemistry of the clasts, then making some comparisons with other conglomerates in the Southern Uplands Down-Longford Terrane, in case you're wondering what SUDLT stands for, and then going into technical aspects of radiometric dating using zircons extracted from the samples, and finishing that part anyway with a sort of big picture interpretation of what was going on in the Silurian at that time. The reason I was interested in looking at this area in the first place was because of my interest in metallurgy and in particular in gold. So there's alluvial gold occurrence in the Western Mournes, and I was trying to find out what the source might be for that alluvial gold. And so I'll finish by going back to that topic. Okay, so the location is indicated by that yellow star in County Down. It's about, using old terminology, about 50 miles south of Belfast. And the host rocks we're talking about are mid-Silurian in age. They're the Hawick Group, which extends right across the Southern Uplands and Longford Down terrain, although the outcrop thickness is much wider in the Southern Uplands. And to zoom in on this, the color coding here, this is a map showing Belfast and County Down and the Ordovician-Silurian outcrop. So we've got the northern belt, which is the Lead Hill supergroup. This is taken from Brouard et al., published in the Scottish Journal of Geology. It's indicated by purple. The blue is the Gala group, which makes up, as you can see, quite a wide belt with several tracks. And the very pale pink that comes out as uncolored on this copy to the south is the Hawick Group. And together they comprise the central belt of the Southern Uplands Longford Down terrane. Then you've got these red areas, which are plutons. So the bigger of the two, the northern one, is Devonian or late Silurian, early Devonian in age. It's the Newry granodiorite. And the smaller one to the southeast of that, to the Mourne Mountains, which is early tertiary or Cenozoic, it's a Paleogene granite. And if we zoom in on that, the Mournes Granite is actually made up of 5 major intrusions, although some of these are subdivided by having pulses of magma. And you can see they're numbered G1 to G5, and there's a progression from the east to the west in terms of the age. And the yellow star again indicates the location of Trainor's rocks, which is this hilltop location just on the westernmost edge of the Mournes Granite. The other important thing to mention out in terms of geographical location is that this location is about 100 kilometers southeast of the Tyrone arc, or Tyrone Igneous Complex, which is Ordovician in age, which doesn't make much sense at this stage, but I'll be telling you what that means later on, because we identify the clasts as coming from that source. So the Mournes is an area which has been thoroughly trodden by geologists over, I don't know, 150 years or so, very well mapped, one would think. And this is the most recent publication on the host rocks to the granite intrusions by Matson et al., published in Geosphere in 2020, showing the fracture patterns. So that the stereonets are the poles to planes. So the dots around the edge indicate that you've got steeply inclined structures. And they were looking at the fracture orientations to get a better understanding about the intrusion mechanism of the granite plutons. It used to be thought that they formed by cauldron subsidence. More recently, Carl Stevenson and co-authors turned that around to say they're actually laccolithic sideways intrusions. And Matson et al. Were testing this by looking at the fracture patterns in the host rocks. And I've highlighted one of their locations, which is Grugandoo. And Grugandoo is just north of my locality, Trainor's Rocks. And they obtained 353 measurements of fracture orientations, but didn't mention anything about what the host rock is, which is conglomerate and gritstone, whereas the rest of the locations around the Mournes is typical fine-grained, siltstones, mudstones, other host rock. This is the Geological Survey map. So we're a bit aware of copyright things here, but this is an extract photograph I took of my copy of the 1978 publication on the solid geology of the Mournes by the Geological Survey of Northern Ireland, showing Grugandoo and Trainor's Rocks. And you can see the contact, if I highlight that with the marker, the mapped contact between the granite, it's the G4 stage of intrusion, and the Silurian country rocks. And it's been mapped in quite some detail and is very well exposed. But the country rocks are just uniformly colored Silurian. And you notice that there are lots of dikes. These dikes are not very conspicuous features in the field, but they've been carefully mapped out. But the variation in the host rock is not mentioned. So if I put that into a topographic map, you can see that we've got 2 river valleys parallel to each other, which run along the line of these 2 north-northeast trending faults, which define a sort of central graben structure, a downfaulted block within the granites, because it's G4 and G5. The darker red color is the G5 phase of intrusion. And the western of the two faults runs, or the valley there is the Leitrim River. And the map, the thickness of the red lines which mark the river courses is proportional to the abundance of gold, alluvial gold or placer gold within the streams. Gold here was known about in the 1980s. There is some evidence that, in fact, it was rediscovered in the 1980s, having been known about and worked in the Bronze Age, early Bronze Age. But nobody knew where the gold came from. And the stars indicate possible locations of concealed sources because there's no obvious outcrop of gold-bearing mineralization in the area. And you can see that gold extends in the river sediments right up to the headwaters of the Leitrim River. Okay, so naturally, I started looking at the rocks in that area. So this is a view looking into the Leitrim River Valley. You can see it's agricultural area with lots of fields. The river itself has been canalized, has been channeled into a particular structure, but would presumably have meandered across that floodplain previously. And we're up on the western flanks of the Leitrim River Valley at the location. The only place name on the map is Trainor's Rocks, south of Grugandoo. This particular outcrop is of hornfelst mudstone. It's fine-grained rock, but just to the south of that, you get into different material. That's some of the gold grains which we've recovered from the Leitrim River. I need to give you a warning that it's hard to come by. It's not easy won gold. It is pretty scarce. So don't go rushing over there with your pan to thinking you're going to make your riches. We have to work pretty hard to get samples. But the gold is interesting because it's got a significant amount of copper in it, about 0.5% up to 2% copper, which is quite unusual for alluvial gold. Usually naturally occurring alluvial gold is a gold-silver alloy, which this is. It's got about 11% on average silver, but it's also got copper, which is unusual for alluvial gold. So I prospected the catchment area, and I found Rhizon veins where hot gases and fluids had emanated through the roof of the granite intrusions into the adjacent country rock and had precipitated tungsten, molybdenum, and bismuth, amongst other things, in veins. And this I published in the Journal of the Russia Society in 2012, along with Andy Tyndall, who produced that lovely colored image on the bottom right, showing ferberite, which is a wolframite mineral, and powellite, which is similar to scheelite, but contains molybdenum, and bismutite. But no gold mineralization. During the course of my occasional visits and exploration, I came across this unusual material along the granite contact at Trainor's Rocks. And you can see that you've got material which looks very like granite. It's a coarse-grained or medium coarse-grained quartz feldspar rock with bits and pieces of other things in there. So you've got these holes which are weathered out fragments of a softer material. And on the right-hand side, you can see in this fresh rock face, this very strange shape, very sort of liquid, deformed shape. And I couldn't really make out what this was. And the answer to not knowing what something is to get a bunch of students to map it. So I suggested this as a good area for undergraduate students to do their fieldwork, their project mapping. And we continued to puzzle over what this rock is. And when I went back in 2015, we found even more coarse material. And at that stage, I was still convinced that it was embedded in a granitic matrix. So we were thinking, is this some sort of intrusive breccia or tuphosite type thing? But I was convinced that the matrix was granite. And this was actually an extract from a student dissertation where I had encouraged the students to say, well, this looks like it's some sort of intrusive rock. Let's call it tuphosite. The following year, I went back with my son, and the penny dropped. I don't know if it was him or me, but between us, we realized this is not an igneous rock. This is a conglomerate, or a gritstone and conglomerate. And what we did was we walked away from the granite, away from the contact, and realized that it's much more extensive, this type of rock, than we thought before. But it just seemed crazy because we were thinking that the country rock to the Mournes Pluton was this homogeneous hornfelst fine-grained mudstone rock, and here we had something quite different. That's a close-up, my fingers for scale, and you can see it's like a pebbly gritstone. In places it is a conglomerate. We call it microconglomerate, but most often it's like a pebbly gritstone. The largest clasts are about 5 centimeters, 2 inches in diameter. And as well as the pebbles, you've got lots of mudstone fragments, which are which we subsequently realize are rip-up clasts of mudstone within this conglomeratic material. Up at the top here, you can see there's a patch which is a pale green color, and subsequently we discovered this as andesite. The lighter color patches are mostly rhyolite, but we also found granite. More students back in September 2019. They're all very excited because they found the west dipping contact of G5 below G4 on Slieve Ruisley, which is just a bit further north. But Eugenie, who's the student on the right-hand side in this picture, took on the task of mapping out the Trainor's Rock Scrug and Dew exposures. So this is her map based on the Ordnance Survey 1 to 50,000 sheet, which we did get copyright permission for at the time, and a kind of compilation of photographs. I'll show you some of these larger scale at various locations around the area. So on her map, you can see the boundary between the granite and the Silurian country rock, which more or less coincides with the top of the steep slope at the western side of the Leitrim Valley, and extends. These grid lines are a kilometre spacing, so it extends over a distance of at least a kilometre north-south, much more widespread than we had previously thought. COVID then intervened, but I came back as soon as I could, which was in 2021, to do more mapping and to collect bulk samples. The bulk samples being for geochemistry and for zircon, uranium-lead dating purposes. So that's a view from the sort of hilltop, which is very undulating and sort of knobbly, looking northwestwards into the granites of the Mournes. Since line of sight was tricky on this sort of hummocky hilltop, what I did was I got the best possible resolution from Google Earth, which was zooming in to Google Earth and getting screenshots of fairly small areas and compiling those rather laboriously into this mosaic. And then I realized that I had to have names of places to find my way around. So I invented lots of names, which is good fun. So we've got a few names which are actually on the map, like Huddy's Loch. I've called it Huddy's Bog because the loch isn't there anymore. And then I've called Polly's Rocks, because that was one of our students who mapped that bit. And then Trainor's Rocks, which I think means this particular area. Trainor's South, Trainor's West Hill, Northern Mounds, Northern Bog, Northern Crag, just so I had some landmarks I could then identify. And the numbered localities in this are waymarked from localities, and I've labeled things like SST meaning sandstone and Cong meaning conglomerate. Anyway, I wasn't expecting you to be able to see that, but just to explain things. And then the next thing is how to actually get samples. Now this rock forms the top of the hill for a reason, and that is because it's extremely resistant to erosion and therefore extremely hard to get samples from. And with an ordinary geological hammer, it would go doing and bounce off. So I thought, right, I'll rent out a diamond-bladed saw, and I lugged this thing up the hill, and I couldn't get a start. Probably just as well. I don't know what damage I would have caused myself, never mind the rocks. So that went out the window. Sledgehammer did the job instead. Okay, so my assistants, Mark Cooper and Brian McConnell, accompanied me on one of the days, and were particularly useful in terms of taking about 25 kilos of rock off the hill after we had obtained samples from various locations. This is one of my localities, Central Cliff. You can see even from this distance that it's got variable grain size. In the central part of the cliff, it's quite coarse grained. Above that, it's more laminated. Then it gets coarser grained towards the top. So you get these variations, but it's quite difficult to map out because they weren't really systematic. My most recent visit was in, actually it's not true, I've been back since once again since then, but March 24, Mike Sims from the Ulster Museum assisted me in one of my 3 days of mapping. And this photograph not only shows Mike, but also shows one of the mudstone rip-up clasts, which reach quite remarkable dimensions. So this one is over 1 meter in length, contained within this pebbly gritstone. And we even found something which looks remarkably like a fossil bone, but I don't think there were marine reptiles in the Silurian. So I think that's just a rip-up clast which happens to look very much like a bone. Some of the rip-up clasts are sufficiently abundant to actually show imbricate structures. They stack up on each other, and the imbrication where you see that suggests that the deep deposit formed by flow going southwards. Mostly it's fairly chaotic in terms of bedding structure, but occasionally you get graded bedding, like you can see in the left here, where it goes from coarse material up into progressively finer material. Then you get another coarse layer on top of that. On the right-hand side, you can see sort of chaotic bedding becoming then more laminated going up. And this was the best example we did see of graded bedding, but this is rare to see this. I'd say only 1 or 2% of the outcrop area actually shows nicely bedded or graded bedded sandstone. This was sandwiched by microconglomerate above and below. Towards the edge, the margin of the outcrop, I'll show you a proper map of the outcrop area shortly, we get into interbedded sandstones and siltstones. And occasionally these show some interesting structures. So here we've got load casting, sagging of the sand layer, and flame structures where the underlying sediment is forming a sort of flame feature going up into that bed. So that suggests that you had soft sediment deformation, rapid deposition of this gritty material on top of mud. And that's around the edge of the main area of microconglomerate gritstone. So that previous photograph that is from that location, just on the central western side. And here we have a nicely laminated sandstone showing ripple crest in cross-section on the northern margin. So the northern margin, if you look at the dip and strike symbols, the bedding dips fairly gently, maximum of 25 degrees, towards the southwest, or southwest, sometimes west, which is quite different to the predominant bedding direction and inclination within the Southern Uplands and Longford Terrane, where normally you see steeply inclined bedding. But anyway, on the northern and western margins, you've got this sort of transitional zone out into mudstone, siltstone, which is the normal Hawick Group lithology. Okay, so the northern margin, based on that structure, seems to be the stratigraphic base of this gritstone conglomerate feature. And we don't see the stratigraphic top because it's chopped off by erosion and by the intrusion of the granite. If I just show you cross sections coming up next, so the north cross section and south cross section. So in the northern area, the Trainor's Rocks area proper, we've got something approaching 40 or 50 meters thickness of gritstone conglomerate. If you project the roof contact of the G4 granite westwards, you can see you've got this reasonably thick body of this gritstone conglomerate with the sandstone, quartzose sandstone underneath. Whereas when you go to the south of the area, it's like a feather edge. You've just got very thin, maybe maximum sort of 10 meters. So if I go back to this, you can see more clearly the outcrop pattern. So I've actually, since this was published in the Journal of the JOSOC last year, I have undertaken a bit more detailed mapping of the southern margin, and there are even some isolated hills of gritstone sitting directly on top of the G4 granite. They've been separated by erosion. Okay, and just to mention the dimensions here, we've got about 1.1 kilometers north-south and something like 400 meters wide feature, which until we did this work hadn't been recognized, hadn't been spotted previously. Okay, moving on to petrography and geochemistry. First thing I did with the material we brought back, which was transported over to University of Brighton, was to use a diamond saw to cut slabs and grind faces to get nice smooth surfaces so we could see what the internal features were. And you can see very clearly they've got pebbles, some of which are very rounded, like this pebble of rhyolite, others which are more angular. There's a porphyritic rhyolite type rock down at the bottom here. The creamy colored areas are crystals of alkali feldspar and quartz, which look like they might have been derived from a pegmatite. You've got gray-green clasts of andesitic material and darker clasts of basaltic rock. And then on the right-hand side, you've got mudstone rip-up clasts, which on the cut surfaces look very dark in color. And you can see very clearly the granite in this upper part of this right-hand side photograph. But this couldn't possibly be Mournes granite because it's been intruded, this rock has been intruded by the Mournes granite. So that these igneous rocks must be an older generation of granite and igneous rocks. So in thin section, we've got features within some of the clasts, which are very interesting. You've got devitrification textures in rhyolite. You've got perlitic obsidian clasts, where you've got all these curved fractures. You've got quite large clasts, which are all just made of potassium feldspar, pegmatite derived. You've got vein quartz. The vein quartz in cross polars shows shadowy extinction, as you would expect. Very rarely do you find things like amphibolites, but there are some amphibolite clasts and also myelinite and zircons. So we found some zircons within the matrix associated with granite-derived quartz, and a few zircon crystals actually contained within granitic rocks in thin section. So all of these lithologies together are pretty typical of a volcanic arc context, arc volcanism. Okay, so if we zoom out and look at the big picture for the Southern Uplands Down-Longford Terrane, here we are, Trainor's rocks, just been showing you the rocks there. There are other conglomerates contained within the terrane. For example, near Newtonards in County Down, further north in County Down, you've got the Palaeocene conglomerate, which I'll show you a photograph of shortly. Across the Irish Sea, we've got the coarse wall conglomerate and the Rins Galloway. We've got the Black Craig Formation conglomerate and central part of the Southern Uplands. Going the opposite direction in Monaghan, County Monaghan, Loch Avalon, it's not actually a conglomerate, but it's a sandstone which has been described by Brian McConnell and co-authors. So these are the formations that we're comparing the Trainor's rocks with in terms of the geochemistry and age dating. The bottom right diagram here after Rice et al. 2018 shows the chronology of archivolcanism and deformation in the Ordovician, and then the sedimentation and thrust imbrication of the accretionary prism forming the Southern Uplands, Longford Down, and then subsequent intrusion in the late Silurian up into the Devonian of granitoid intrusions, such as the Nuri granodiorite that I mentioned earlier. Okay, I included in this set of photographs not just the Palaeocene conglomerate in the center and the coarse wall conglomerates on the right, but also one a photograph supplied by Mark Cooper of a very coarse conglomerate further west. If I just go back one slide, Lisbelaw is towards the western extremity of the outcrop of the Southern Uplands down Longford from terrane. And all of these have much coarser clasts, so that we're talking about cobbles and boulders, in contrast to Trainor's rocks, where the biggest clast size was about 5 centimeters. Okay, so we've got some geochemistry. Steve managed to get 5 of my samples analyzed at BGS Keyworth for geochemistry, and compared those with geochemistry of clasts from the Palaeocene and coarse wall conglomerates. My voice is starting to go, sorry. Okay, so the color coding on that previous slide matches the one on here. So Trainor's rock samples are in green, coarse wall in blue, Palaeocene in red. And I need to explain that 2 of the Trainor's rocks samples are composite samples. They're bulk samples. So that's TR1 and 2, whereas 4, 5, and 6 are clasts. They're actually composite samples. So because the class size, I said maximum 5 centimeters, but the ones which I was able to actually separate, by the time you separate the matrix, you tend to have class fragments which are only 1 or 2 centimeters in size. So I had to make up a composite set of these. So composite sample of basalt class, composite sample of andesite, and a composite sample of rhyolite class. And very pleasingly, they plot in the appropriate fields within the discrimination diagram. And they show a calc-alkaline differentiation trend. So TR4 arguably could be tholeiitic, the basaltic clasts, but 5 and 6 are definitely on the calc-alkaline trend. And we have similar trends shown by the samples from coarse wall and Palaeocene, but I'm not going to focus on those today. Using immobile element geochemistry discrimination diagrams, this is all by Steve. We can see that, again, the clasts are typical of arc volcanism. They plot in the pink colored field here, which is TVG arc lavas and latent intrusive suite. So TVG is Tyrone volcanic group. And we were starting to get the picture that the Trainor's rock samples could well be derived from the Tyrone arc, which I mentioned earlier. I'll move on. Okay, so 4 of the samples were sent off to SU-ERC for fragmentation using electric shock methods. It's called self-frag. I think I probably should put a C after the self-frag, which basically uses sort of controlled lightning to fragment the rock without actually breaking across the crystals. And this is in order to separate zircons, which has quite a laborious process involving sieving and hand picking, and then imaging by various methods. We spent a year trying to get funding for the zircon uranium lead dating, which wasn't successful. So eventually I bit the bullet and said, okay, I'll pay for it. And negotiated with the University of Granada in Spain, who have an IBER-SIMS facility using sensitive high resolution ion microprobe, or SHRIMP. I sent them 100 zircons and they managed to get dates for 75. I just need to explain that the purpose of this dating was primarily to establish what the youngest age of volcanism or magmatism represented by the class in the Trainor's rock conglomerate. What I didn't say when I showed you the map earlier is that the Trainor's rocks conglomerate is the stratigraphically highest of the various conglomerate formations within the Southern Uplands Down-Longford Terrane. So the dating was to find out if magmatism had continued relatively close to the time of sedimentation, which is in the Wenlock stage of the Silurian. So we deliberately focused on zircons which showed evidence of crystallization from magma. And the key thing for that is that you get growth zoning in magmatic zircon. You get sort of oscillatory growth zoning, which shows up beautifully under cathodoluminescence. So these black and white images are cathodoluminescence imagery of cross sections through zircon grains. And zircons often show complex internal structures due to inheritance of older zircons and then more crystallization of magmatic zircon around those older cores. So in most cases, we analyze the outer parts, but in some cases, we analyze both inner and outer. And we also analyzed a few examples of unzoned zircon. So invariably, there'll be a degree of bias in the results because we did focus in on the magmatic, likely to be magmatic zircon as opposed to metamorphic or metamorphosed zircon crystals. Okay, and this is the data we got for 70 analyses. The previous slide said 75. 5 analyses we had to reject because of very rarely common lead occurring within the zircon. Only 1 zircon showed that. Or if I go back a slide, a spurious, at the top right, a spurious age of 290 million years, which I think is Carboniferous, due to exceptionally high uranium and lead content within that particular zircon. So we ruled that one out. So 5 were ruled out, but we're left with 70. And the age distribution is quite remarkable. And you've got this huge peak in the lower Paleozoic, and that accounted for 48 of the analyses. And the remainder spread across the Proterozoic back to, well, early Proterozoic. So if we just take the Phanerozoic, Paleozoic ages, they form a nice bell-shaped distribution, as you can see, sort of unimodal distribution, which suggests that they've come from one particular source. To make sense of this, you need to compare it with other data sets of zircon ages. So we looked at Grampian terrane, the Tyrone central inlier, which is a Dalradian fragment within County Tyrone, the South Mayo Trough, likewise, Southern Uplands data, which is a much, as you can see by the numbers here, very big data set. And then Brian McConnell's data from County Monaghan, the Loch Avon Formation, where he had data for 2 samples, one of which is predominantly Paleozoic ages, and the other one which has much less Paleozoic, but more Proterozoic ages. And you can see that if you look at the pie charts, the pie charts show the proportion within these age categories. So one of Brian's samples from County Monaghan, sample 1410, is quite similar to the Trainor's Rocks County Down sample. And in the Southern Uplands in general, you have something like a fifth of the zircons tend to be Paleozoic, and the rest are older. Okay, if we look at the shrimp age data in a bit more detail for the lower Paleozoic ages. So this is a stratigraphic plot turned on its side. So we've got Cambrian going through Ordovician and then Silurian. And we know that the deposition of the Hawick Group sediments, which includes the Trainor's Rock Formation, was in the Wenlock. So we're around about 430 million years. And the green bars here show the 1 sigma ranges of the zircon uranium lead dates. Now shrimp, the ion microprobe method doesn't give you such precise dates as other methods of age dating zircons, where you can get plus or minus of less than 1 million years. Here it's more like 5 or 6 or 7 million years. So they're quite wide age ranges. If we take the mean of all of these zircon ages, it comes out at 468.6 plus or minus 1.9 million years. But that's effectively meaningless because it's not all from one sample. This is, these are zircons separated from a conglomeratic rock. So they're from different rocks originally. Nonetheless, that mean corresponds pretty well with the age of volcanism in the Tyrone Igneous Complex, perhaps also extending into the continental arc granites that superseded or came after that. We've got a few zircons in that group that are older. We've got that annotated. Zircons older than the Tyrone. These ones couldn't possibly be from the Tyrone Igneous Complex in that even with the 1 sigma range, they fall outside the range of dates that Steve and others have got for the Tyrone volcanic rocks. And we've got a few which are younger. So at least one zircon is definitely younger than the Tyrone Igneous Complex. Now, this particular, you can't really say on the basis of one zircon whether volcanism continued up to a few million years before the deposition of these sediments. But nonetheless, there's a very good hint there that that maybe not all of these zircons are actually from the Tyrone complex, but could be from other volcanic centers in the hinterland. How are we doing? Okay. Right, this is another stratigraphic plot, which is based on Mange et al. I've forgotten the year, but we incorporated it into, or redrew it for our Journal of the JOSOC article last year. This is where I show that the Trainor's rock, pebbly gritstone microconglomerate, is, as far as we currently have information for, is the youngest conglomeratic rock within the Southern Uplands Down-Longford Terrane. The Palaeocene is within the Gala group. It's not only maybe 3 or 4 million years older. The Monaghan sands that Brian McConnell analysed are early in the Gala group, and then the coarse wall and Black Crag formation are Ordovician in age. Okay, the blue bands here show the age ranges of the Moffat Shale. Now, the Moffat Shale isn't so chronologically constrained, so it represents the abyssal plain deposition at the same time as you get greywackies and turbidites sediments being deposited. And the Trainor's rock conglomerate is in the Hawick Group, coincidence with the last of the formation of the Moffat Shale. I haven't explained that very well, but basically from this time onwards, there wasn't an abyssal plain for Moffat Shale facies sediments, oceanic facies sediments to be deposited. Notice, by the way, that we've got granite cobbles within the Palaeocene conglomerate, which haven't yet been dated. So if somebody has a few £1,000s to spare, then we could get on with dating those as well. Okay, so let's... So we're 2 more stages in the talk, looking at the geotectonic context of deposition of this formation, and then going back into could it be the source of the gold in the alluvium. Okay, so we've matched the clasts, the composition of the clasts, and the zircon ages between the Trainor's rock gritstone microconglomerate with the Tyrone arc. And if we look at a big picture, we had the Iapetus Ocean closing. So we had Baltica and Avalonia and Laurentia approaching each other at 430 million years, which is during the deposition of the Hawick Group, the Wenlock. So I put a pink star in here indicating schematically where Trainor's rocks might be. Now, I don't think, well, we're pretty sure from the data we don't have any sediment from Baltica coming in. So basically it's Avalonia or Laurentia. In fact, there's not really much evidence of Avalonian sediment coming in. It seems to be all from Laurentia, which is basically the landmass which includes the Dalradian supergroup. So something like this, where we had a hinterland, which is the source of the sediment, and riverine transport of sediment, possibly a delta, but that's not necessary. Then going into a canyon feature on the continental slope, and sediment being transported in turbidity flows into deep water. So these are extrabasinal turbidites going down into the abyssal plain, the deep ocean. So that's the kind of scenario we're talking about, with a distance in the order of 100 kilometers between the hinterland and the deposition site. So Mark and Steve put together, Mark drew it in hand drawing and Steve converted it into a nice computer graphic, this conceptual diagram of what was happening in the mid-Silurian. So here's our Trainor's rock submarine channel deposition. I didn't mention before, but the long axis of the outcrop, which is north-northeast trending, aligns with the trench, the ocean trench. You had the Iapetus Ocean undergoing the ocean floor, rocks undergoing subduction. But the hinterland to the northwest comprised both Grampian terrane, from which you have the metamorphic clasts like metamorphic quartz and amphibolite and myelinite, and also the Midland Valley Terrane, which includes the Tyrone volcanic group, which is shown in red color on here. At the time of erosion, you didn't have exposure of the deeper levels of the Tyrone complex. So the plutonic group and the Tyrone central inlier were not yet exposed, at least at the location where the riverine sediment was being derived. Okay, and you had incision and erosion of great whitecases and mudstones of the increationary prism. So you had rip-up clasts of previously deposited Hawick Group mudstones being incorporated into this turbiditic flow. Okay, also shown on the diagram are fossil channel deposits. So the Palaeocene conglomerate might be sort of one of these features from a previous period, which has now been stacked up in the accretionary prism. So the big part of this is sinistral tectonics. So you had sinistral movements along what's now represented by the Southern Uplands Fault and the Highland Boundary Fault and other tectonic boundaries, helping to expose these rocks in the hinterland for erosion. As I showed earlier, the youngest zircon is something only several million years older than the Tyrone volcanic group. So it could be that all of this uplift and exposure was taking place in a pretty short time frame of a few million years. And finally, could the Trainor's rock conglomerate be the ultimate bedrock source for gold in the area? Now, I need to be careful here that I'm not suggesting that the conglomerate itself contains grains of gold. What I'm saying is that the conglomerate could have been the source rock for gold, which was deposited in hydrothermal veins. We've seen that there are Greisen veins in the area which contain other metals, tungsten, bismuth, molybdenum. Hydrothermal veins containing gold we haven't found, but then they may have been in the roof, which has since been eroded away, and the gold may be a residual feature on the landscape. So if you look at the alluvial gold distribution, I've indicated the number of gold grains at panning sites, and just to explain, I have been looking at this for quite a few years. So there are a lot of small streams which have been panned. We got 100 gold grains, well over 100 gold grains from the lower part of the Leitrim River. That was about half a day's work with 3 people working fairly intensively. 81 grains further upstream. Then it drops off when you get up to the headwater. But I then followed the gold, as it were, up into one of these headwater streams, which directly drains from the Trainor's rock area, and got 21 gold grains. So it looks like it's coming from that area. And if we look at the composition of the gold, I mentioned earlier it contains copper. I don't really want to go into this, so just notice that there are 6 sort of color-coded divisions in these pie charts. And notice that the pattern in the pie charts in the Leitrim Upper Bann area is all much the same. But when you go outside of that area, you get very different distributions. So for example, this location, Tamari, over to the northwest, doesn't have any of the copper-bearing gold. Likewise, Moygannon Lower doesn't. And when you go down to Ballincurry in the south, you've got a very different pattern where you've got lots of copper bearing gold. But in the Leitrim area, it's all kind of much the same distribution, okay, which would suggest, to me anyway, that you've had homogenization and or a single source ultimately of the gold. And the significance of the copper is that copper enrichment in gold is associated typically with magmatic hydrothermal fluid transport, as you would get in a porphyry or an epithermal system. Otherwise, copper tends not to be found within gold crystals. So there's a component of magmatic hydrothermal input in the Leitrim area, which is much more obvious in the Ballincurry location down to the south, which suggests there's a very small but very rich local source of magmatic hydrothermal mineralization, which we haven't located in that area. Okay, so gold, I'm suggesting, is enriched in this area because of the conglomerate and hydrothermal fluids from the Mournes granite interacting with kind of juicy lithologies of the conglomerate. The igneous lithologies have liberated gold, which has then gone into hydrothermal veins, probably quartz veins, which have been eroded and the gold liberated and is now in the river system. The reason I'm arguing for that rather than, say, glacial transport of gold from County Tyrone is that there are major differences between the gold composition in County Tyrone and in County Down in the Mournes. The alloy composition is different, the lead isotope composition differs, and there isn't a kind of a trail of alluvial gold occurrences all the way between Tyrone and the Mournes, which you would expect if there'd been some sort of glacial transport. Anyhow, you don't generally get glacial transport of gold of that sort of distance, 100 kilometers. So something else must account for it. But this map, published in 2016, showing gold anomalies in subsoil in Northern Ireland, shows there are lots of little spotty occurrences, like nugget effect occurrences of gold, and maybe some of these could also have been a result of a similar process of transportation southwards into the Iapetus Ocean from the Tyrone volcanic arc. Okay, so I was keen to fill in a gap, which is to pan the Gan River south of Trainor's Rocks, which I did with my sluice and pan equipment in March 2024, and I found no gold. So the gold is in the Leitrim River Valley to the north, but doesn't seem to be present to the south of Trainor's Rocks. But that does kind of reinforce the idea that it's a localized occurrence of hydrothermal vein gold, which is the ultimate source, not actually the conglomerate as such. Okay, to summarize, okay, the Trainor's Rocks gritstone conglomerate, it's regionally significant because it appears to be the youngest coarse clastic unit within the Southern Uplands Down-Longford Terrane. It's not the only one, but it seems to be the youngest, and it's rich in these extraformational clasts, which tell us a lot about the hinterland, including granite, rhyolite, andesite, basalt, which are from the volcanic arc rocks, vein quartz and metamorphic rocks likely to be from the Grampian terrane, the Dalradian supergroup, plus then the intraformational rip-up clasts of Hawick Group, mudstone, siltstone. The zircons yield mainly Ordovician, uranium-lead ages, peaking at 470 million years, which is coincident with the timing of arc-related magmatism in the Midland Valley Terrane, such as the Tyrone arc. And the class geochemistry is also consistent with derivation from a calc-alkaline volcanic arc source, and in particular a continental volcanic arc as opposed to an oceanic arc, which again matches very well with the Tyrone Igneous Complex. So we interpret as a deep marine within the Iapetus oceanic trough, deep marine channel fan deposit, which fairly shortly predated by a few million years, perhaps, the final closure of the Iapetus Ocean, while the hinterland was undergoing episodic tectonic unroofing in response to sinistral strike-slip movements. Interestingly, if you look along strike in the United States and the Appalachians, you find that the dating differs. So you had in places in the Appalachians, you had closure of the Iapetus Ocean in the late Ordovician as opposed to the mid-Silurian. So it looks like you had sort of diachronous closure. It's a messy closure. It wasn't just a simple ocean closing. You had it closing in some areas while still open elsewhere. And the gritstone conglomerate formation might be the ultimate source for alluvial gold, but that's very difficult to prove. So that remains as speculation. Okay, so thank you very much for listening to all of that, and I'm very happy to answer any questions.